Hi, good morning and good afternoon, everyone. Thank you for joining us today for this new webinar in the month of July with the Several Nines team. My name is Jean-Jérôme and I'll be looking after you for the next hour. Thanks for joining us today. The session today is on MongoDB monitoring, and my colleague Art van Schepping will present to you on this topic today. But for now, I just wanted to ask all of you a quick question, if I may, and this is just to get the conversation started, but it's to ask whether all of you who are participating today are currently a MongoDB user or not. So it'd be great if you could participate in this poll, and that will help us understand a little bit your background, and then we can get started with the actual presentation. So thanks for your participation here. And I'll share the results, of course, of your answers, just so you can all see the participation today. Thanks for this. I'm just going to close this now and share the results. Okay. So this is great to see. So the vast majority of you are already MongoDB users or are planning to start using MongoDB. So that's really good to see, and I'm sure that's good background information for Art once he takes over. Just before we begin with Art's presentation, I just wanted to let you know that the session is being recorded, and we will make the recording available to you, of course, after the webinar. If you have any questions during the next 60 minutes, feel free to ask them by using the question section of your control panel, and we'll be happy to answer them towards the end of the webinar, or indeed feel free to email us at info@severalnines.com, and we'll be able to help you there as well. But for now, I'll hand over to Art for the presentation on how to monitor MongoDB. Over to you, Art.
Thank you, JJ. Good morning. So today we're going to cover MongoDB monitoring, and especially focused upon if you're already in MySQL DBA. So you would probably know a lot of ins and outs of MySQL monitoring. So we're going to follow a short agenda on making the difference between trending and alerting, then why we collect data, and then we're going to see how MongoDB actually compares to MySQL in monitoring. I'm going to focus on a couple of MongoDB metrics you should really know about, because some of those metrics they are similar to what you're used to at MySQL, and they're equally important. Going to cover the open source MongoDB monitoring tools, and then how you can monitor MongoDB using ClusterControl, including a demo at the end. And of course, at the end, there's room for questions and answers. So if you have any questions during the demo, please enter them into the console, and we will pick them up in the Q&A at the end. So trending and alerting. First of all, why do we actually need a good trending system? This picture kind of describes why you really want to have a proper monitoring system, because you don't want to end up without knowing what is going wrong until your database cluster all of a sudden crashes and you have an outage of your database cluster. You have to go back and try to figure out what went wrong, and you didn't collect any data on the systems, and therefore you will not know if anything has changed in between. Maybe you can look at a couple of log files, but that's about it. You don't know anything about how the operating system performed, or maybe the database had any logs. So monitoring versus trending. Well, we have monitoring systems like Nagios, where the system actually checks whether your service is healthy, if it's still available. And it can send out alerts, so it can page you via PagerDuty, for instance. While the trending system is something different, where you have Cacti and Graphite collecting data continuously, all sorts of metrics. And then you can generate graphs, and you can look at trends, and then see what is happening. And also for instance, a post-mortem, you really want to have this data later on, while a monitoring system only keeps for a short while its current state at the best. So for monitoring, one of the advices we can give is just do more than just opening up a connection. For instance, in Agios, you can check your system by opening a connection to MongoDB and just assume everything is fine, while actually you really want to measure whether your nodes is still up, if you can read and write certain specific databases and collections, or if they are present. You also want to keep an eye on the replication lag. If one of the servers is lagging too far behind, you want to alert on that. And also you want to check on the full topology. So suppose you have a cluster of 5 nodes. You want to see whether all 5 are fine, and maybe one of them is at fault. But you want to know how many nodes you still have left. Trending, why do you want to have trends? I already mentioned a couple of reasons why. Well, with trending, you can keep those metrics for a longer period of time, and then you are able to find, for instance, problems before they actually happen. You can see the disk space being eaten up. So you can act upon that, add more disk space if necessary. So this is really good for preemptive problem management. Also, for post-mortem, you really want to have a trending system, because then you can look a week later or a few days later into why did it happen, why did all the accumulation of connections all of a sudden become a problem. For training tools in general, you really want to have a fine-grained set of metrics, because the more data points, the better. Suppose you would collect only once per minute the number of connections, and you would get a connection burst every, let's say, minute for maybe 1 or 2 seconds. You wouldn't see that when it's getting averaged out if you're collecting only once per minute. So you really want to have a fine-grained set of metrics. So the more data points, the better. So why would we collect data? I've named a couple of them. Periodically, health checks, you want to look at your systems on a daily basis, maybe on a weekly basis, dive into certain specifics. It gives you a better insight in what is happening in your database system than actually just looking at it right now. And you can also, for instance, plan certain let's say you want to add another shard to your MongoDB system. You can plan that better by looking at when is the least amount of traffic coming into my system on a daily basis. So, for instance, at 3 o'clock in the afternoon would be the best time to do that. I mentioned post-mortem and proactive monitoring already, and capacity planning. You can see that, for instance, CPU is getting eaten too much, and you would need to add an additional slave for that. So health checks themselves are really a pain, because you basically want to see all the data together. You want to see an aggregated view of your cluster. You want to be able to then zoom into, for instance, a single host. You want to zoom into one certain aspect of the metrics. And you want to see what is important, let's say a window of a day, and then dig into whatever you think is interesting, like a small peak somewhere later on. For post-mortem and proactive monitoring, you would be able to dig into what happened. You can see a couple of spikes here. You would be able to zoom into that. And as I mentioned, the granularity is really important, because you can catch certain issues, the finer metrics you are collecting. So, like I gave the example of the increased number of connections, a connection burst happening once per minute, you wouldn't see that if that gets averaged out. And you can see here clearly that with this fine-grained view, you already see a burst coming in. It also gives you good insight in what is happening in your system. Are there any trends in there? And you can see whether you need to plan to add additional slaves or additional disk space. So how does MongoDB monitoring compare to MySQL? Well, actually, it's quite similar to MySQL. You still have to collect the same type of metrics: host metrics, operational metrics, storage engine specific metrics, and replication metrics. It's a database system, so most of the functionality will be quite similar. So host metrics, why do you need to collect that? Well, it's similar to any other database. You have a piece of hardware that you want to keep an eye on. You want to see how many, for instance, how much memory is consuming, whether the network is getting saturated, and that allows you to do capacity planning. You can also determine specific types of issues. So you see something happening in the database, and then you can correlate that to I/O or CPU or network. So that's also the reason to collect those host metrics. Then what happens when you have a high CPU utilization? Well, probably you should add a couple of more nodes to the cluster because it cannot handle the workload at all. If only the primary node of MongoDB is having high CPU utilization, then you probably have to think about your write set. It's getting, you cannot scale that out by adding newer nodes. For network utilization, of course, MongoDB has a lot of networking going on in the background by replicating data to the other nodes. So it's important to keep an eye on your network utilization. As it's saturating, the replication will also start lagging behind. So maybe it's time to upgrade your network, or maybe look at some things that can be done more efficiently. Ping times, basically similar to what you have in MySQL or Galera. How bad is latency affecting MongoDB? Well, actually, it is really important because within a MongoDB cluster, the primary node within the cluster gets elected upon the ping time. So if ping times really get worse between some of the nodes, it's less likely that those nodes will be elected as the new primary once the primary has an outage. Disk throughput and IOPS, similar to MySQL, data has to be written to disk. So am I saturating my hardware? So maybe it's time to upgrade to, for instance, SSDs, or if you're running in the cloud, to go for a faster I/O node. For disk space, do you have to plan larger disks? That's quite reasonable. And memory utilization, you really want to keep an eye on that, because once you hit a certain threshold, OM killer can still come by and kill the Mongo process. Operational metrics. Operational metrics is basically whatever the database is doing itself. So it's also similar to other databases. MySQL has a lot of operational metrics, like the number of connections, the number of selects, the number of inserts, update, deletes. And that's similar in MongoDB. You still have to perform inserts, updates, deletes. And you can then relate anything happening here with the entire cluster. And then you can look at the overview. Is everyone getting, all the nodes in the cluster getting an equal number of read requests, or is there something going wrong here? You can also determine all sorts of issues by this. For instance, request spikes. So you can see a lot of requests coming in. You can see whether you have write amplification. If you get too many writes at the same time, clients have to wait for that, and you get another write request coming into the database for the exact same document, which creates logs. So that's also something you want to keep an eye on. Same for queuing. If that happens, the number of connections coming in could spike out, but we'll get to that later on the MongoDB specific metrics.